Hello students, my name is Sumit Sagar Hota. I am a PM and a PhD scholar at IIT Palakkad. Today we will discuss the summary section by Professor Ashok by all the lectures from Professor Ashok Desar, that is week number 1 to week number 12 by of the subject Turbulent Combustion Theory and Modeling by NPTEL. Okay, in these sections from the starting lectures to the end lecture, some of the important problems, some of the unsolved problems I just going to go through. Okay, so we'll just quickly solve some of the problems. Okay. All the problems are taken from this textbook, SR10 third edition, and it Introduction to Combustion Theory and Modeling, and from sunfoundry.com. Okay. So this is the first problem. The lower heating value of the methane is 50016 kilojoule per kg. Determine the heating value per mass of mixture, per mole of air fuel mixture, per cubic meter of air fuel mixture. So let's quickly solve this question. Okay. You just write down the chemical reaction for the methane combustion. For methane, x is equal to 1, y equal to 4 for CH4. We are assuming the stoichiometric condition. A is equal to x plus y by 4, which is 1 plus 4 by 4, 2. A we get as 2. So we have to find out the air fuel ratio by mass basis. The formula we already know, 4.76 A molecular weight of air divided by molecular weight of the what? Fuel. Okay. So if you solve it, you will get 17.12 kg of air by kg of CH4. Okay. Now we need to find out fuel by air plus fuel, which is 1 by 1 plus air by fuel. If you do it, you will get 1 plus 17.12. Okay. We keep it as it is. You should know the unit, which is kg of fuel by kg of mixture. Now we have to find out the lower heating value in terms of kilojoule per kg of mixture. So lower heating value kilojoule per kg of fuel into 1 by 1 plus air fuel ratio, okay, which is having this having unit kg of fuel by kg of mixture. So this kg of fuel get cancelled. Okay, so just substitute the values. You substitute it, you will get okay. So lower heating value per kg in terms of kg of mixture you now find out. Okay. In the similar way, we will now find out the air fuel ratio, lower heating value in terms of kilomole of mixture. Okay. So air fuel ratio in molar basis, what is the value? Which is 4.76 times A. Okay. Which is 4.76 into 2 equal to 9.52 kilomole of air divided by kilomole of fuel. Okay. So now what is fuel by air plus fuel in terms of what? Molar basis, which is equal to 1 by 1 plus air fuel ratio okay. So now we have to find out the lower heating value in terms of kilomole of mixture. If you see it, the formula will be LHB into molecular weight of the fuel into 1 by 1 plus A by F. You see all these units, kilojoule of per kg of fuel into kg of fuel by kilomole of fuel into kilomole of fuel by kilomole of mixture. Okay. Now if we can see, we can cancel kg of fuel, kilomole of fuel, kilomole of fuel. So the final unit will be what? Kilojoule per kilomole of mixture. Just substitute the values. If you solve it, you will get this value. Units are the important things in this type of questions. Okay. The next bit will be lower heating value in terms of kilojoule per meter cube of mixture. Into N by V. N by V leads to kilomole of mixture by meter cube. Okay. So we are now assume the ideal gas assumptions. PV equal to nRUT. So N by V equal to P by RUT. So N by V will get you see these units, kilomole of mixture and kilomole of mixture get cancelled. The unit will be kilojoule per meter cube. So now you have to just substitute. Okay, so this is the answer. Let's go to the next question. The higher heating value of a liquid octane at 298 Kelvin is this much, and heat of vaporization is 363 kilojoule per kg. Okay, so there is two data, 47893, and heat of vaporization also given 363 kilojoule per kg. Okay, higher heating value and heat of vaporization, that is HFG, given. Okay, we need to find out enthalpy of formation at 298 Kelvin. Okay, this type of simple questions we can expect. So how we will find out? So you know by first law. So at steady state, higher heating value is calculated at steady state. So we have to assume the stoichiometric condition. The reactions is for the octane. So we need to find out the A, x plus y by 4 of the octane equal to 12.5. So for the product, what is the heat of reaction? We have to only consider the product species multiply with their number of what moles. Okay, for the enthalpy of formations. Nitrogen is already existing in this universe, so no need of formation of this, so this is 0. Okay, the other values you just substitute. Okay, this is the HP of the at 298 Kelvin. Similarly, in the reactant side, we have to again find out the enthalpy, heat of reaction, whatever. So for the reactant part at 298 Kelvin, the enthalpy formations are so O2 and N2 already existing in this universe. So their enthalpy formations at a normal atmospheric condition is what? 0. So we know higher rating values, the data already given. Okay, so now we have to substitute all these things in the equation number 1. Let this as equation number 1. What we will get? This is having unit kilojoule per kg of fuel. Okay, but we have to multiply with what? Kg of fuel divided by kilomole of fuel. Okay, then only this unit will match, because if you see, the unit of this is kilojoule per kilomole. Okay, and here the unit is what? Kilojoule per kg. You have to match the unit. Okay, so that's the reason why we have to multiply with what? The molecular weight. Okay, in one word you can tell. Okay, so if you see, kg of fuel get cancelled. Okay, the molecular weight is what? 114.23. Okay, so if you solve it, you will get your final result as minus 250 273 kilojoule per kilomole of fuel. Okay. Okay, so this is the answer. Okay, if you see the question here, whatever we find out, this is for liquid, not the vapor. Because if you see the question very carefully, see they asked octane vapor. Okay, so whatever we now find out is the octane liquid, not the octane vapor. So obviously there will be two options. These two options will be there. One is octane liquids answer will be there. One way they will give you octane vapors answer. If you choose octane liquids answer, then it's absolutely wrong. Okay. That's the reason I solved the octane liquid first. Then we will go to octane vapor. So it's in the same way. The formula for octane vapor will be what? You have to do one more step. Plus HFC. Okay. That is the reason why this 363 is given. Okay. Okay. So now the answer will be 208807 kilojoule per kilomole. Okay, this is your answer. Okay, so we'll just quickly some of the questions. Maybe we can. Some similar concepts are there. You can please keep this. 2.27. I think we can skip this also. Yeah, chapter 4 we will solve one problem. Okay, so this problem will solve. The NO formation mechanism is okay. Okay, this question is looking very big, but it's very simple. Okay, so if you see in the question, some of the elementary reactions of NO formations are given. Okay, of which is extended Zeldovich mechanism. Okay, some of the what they ask the steady state nitrogen atom concentration, neglecting the reverse reaction, NO formation. Okay, NO formation rate they asked. Okay, neglecting the reverse reactions. Only that means only forward reactions are what considered. Okay, so I'll directly write down what are the things given, everything same. Directly write down the solution. Okay, here dN by dt is equal to. Okay, so if nitrogen atom is there, okay, and there is two or three reactions, you see where there is nitrogen atom formation is there. Okay, for example, in the if the nitrogen atom is there in your product side, that means it is a positive one. If it is there in the reactant side, that means it's the what negative sign will come. Okay, that's the whole idea of this type of questions. Obviously they will ask you or give you one elementary reaction and then ask you to find out the formation like that dN by dt, what is the value. Okay, so this type of questions, very simple MCQ questions we can expect. Okay, and 0, why 0? Because of steady state, we are assuming steady state condition. Okay, the what is nitrogen atom, then just make it 0, balance it, find out the nitrogen atom concentration. Okay, in the similar way, if you can also find out the what dNO by dt. So what I now I am going to do, I have n. Okay, I already find out n from here, n's concentration. I'll just substitute in this equation where there is n's concentration available. Okay, so there we will get a simpler expression for what dNO by dt. Now by taking common, K1F O N2. If you take the common, it will be 1 plus 1 by K2F O2 plus K3F OH. Okay. Now if you see these two terms are same, so these two terms can be cancelled. Okay. So the simplest expression. Now it is becoming 1 plus 1 what? 2. So 2 times K1F O N2. Okay. Okay. Okay, this is similar one. Let's keep it. Now we'll just quickly solve some of the MCQs. Okay. Okay, the terms accounting for turbulence effects contains what? Obviously, the answer for this is what? Reynolds stress. Okay. So in high Reynolds number turbulent flows, dash terms dominate. Okay, the term which is affecting the what? Turbulent effect will dominate. Okay. So express the large scale velocity in terms of K and F signal. Okay. So let's the velocity scale B for large scale velocity or large scale ADs. Is equal to K to the power 1 by 2. What is K? Turbulent kinetic energy. Okay, now what is the length scale? For large scale ADs is equal to K to the power 3 by 2 by epsilon. Okay. Okay. So if C mu be a dimensionless, all these things express the AD dynamic viscosity we need to find out. Okay. So turbulent flow for K epsilon model, the formula will be rho C mu K square by epsilon. The answer is what? A. Okay. For the molecular diffusion of liquids, if the diffusion molecules have criteria steady state diffusion of B over non-diffusing A, then n flux of A is what? Okay. Now one condition here is written, very important condition, steady state diffusion of what? B. When steady state diffusion of B given means what? Over a what? Non-diffusing A. That means one is diffusing, one is not diffusing. Okay. That means what? A is non-diffusing. It's given. If A is non-diffusing, what does it mean? N flux of A is what? 0. Okay. Because it's non-diffusing. Okay. For a liquid molecule's diffusion of A and B, steady state equimolar counter diffusion of N flux of A is negative of N flux of B. Is it true or false? Obviously, it's a true statement. Okay. For equimolar counter diffusion, this is the concept. Okay. N flux of A is minus or N flux of B. Okay. This is actually one problem. Okay. Find the change in the concentration of steady state equimolar counter diffusion if dAb equal to 6 square meter per second, change in distance is 2 meter and the N flux of A is 5 mole per square meter second. Okay. So formula is N flux of A is equal to dAb by Z into concentration. Maybe I can substitute as C. What is C? The concentration difference. Z is your what? Change in distance. And dAb is steady state equimolar counter diffusion. Okay. So if you solve it, 5 equal to 6 by 2 into C. So what is C now? C is equal to 5 by 3, which is 1.67. Okay. Your answer is B. Okay. Okay. Okay, one more same problem we can solve. Find the diffusivity AV square meter per second influx of air is given. Concentration difference is 2 molecule per cubic meter and distance is 3 meter given. Okay, just substitute and get the answer. So n flux of air is equal to DAB by Z into concentration difference. So 5P is equal to DAB by 3 into 2. So DAB by 3 is equal to 5 into 3 by 2, which is 7.5 meter square per second. So your answer is what? C. Okay. Okay, this is the last problem of the section. Estimate the mass burning rate of 1 mm diameter X and droplet burning in air at atmospheric condition, assuming no heat is conducted into the interior of the liquid droplet and that droplet temperature is equal to the boiling temperature. Ambient temperature is this. Okay. Just 1 second. No, actually I'm checking this problem is covered or not. Yeah, this problem is not covered. Okay. See what are the things given. All these things are mentioned. Okay. Just we write down the assumption and solution directly. I just go through it. Okay. So m dot f, what is m dot f? Is equal to 4 pi kg rs divided by cpz into ln of 1 plus b of q. Okay, what is the formula for b of q? So there is no heat to in the interior, so this is 0. Okay, so now we find out the T bar. 1 by 2 TF plus TS. Okay, and TS is equal to T boil is equal to 342.1 Kelvin. TF we already know, 2000 Kelvin. So if you substitute, we'll get as 1271 Kelvin. Cpz is equal to Cp of hexane at 1271 4390 joule per kg Kelvin. Okay. Find out Kf is equal to K of hexane at 1271, which is beyond curve fit limit. We know K2 is equal to K1 into T2 by T1 to the power 1 by 2. Okay. At 1000 Kelvin, table B3 yields K as 0.13525. If we approximate as ideal gas, okay. Now what is Kf, which is K1? Zero point 13525. The temperature 12712, 1000 Kelvin to the power 1 by 2. Solve it, you will get 1525 watt per meter Kelvin. K infinite is equal to K of air is equal to 0.08347 watt per meter Kelvin. Kg 0.4 kf plus 0.6 kg. Okay. Okay. So Kg is equal to 0.111 watt per meter Kelvin. Okay. Okay. So now we again know HFZ is equal to 335 joule per kg, delta SC 45101 joule per kg, table B.1 we taken this. Now stoichiometric ratio, nu is equal to 4.76 times A, molecular rate of air, molecular rate of the fuel. Now we need to find out m dot f. First of all, we find out BOQ. Okay. Okay, this is the answer for m dot f. Okay. So thank you very much for attending the section. If you have any doubts, you can ask in my YouTube channel, Sumit Sagar Hota. Okay, in the comment section. Okay, this is the summary section. Some of the problems, important problems I solved in this section. Okay, if you have any other doubts related to your lectures, you can ask in your question and answer forum by NPTEL. Okay, so mostly my problems are from books SR Turn. Okay, from the exercises. Okay, and some of the MCQs I taken from sanfrontier.com. So best of luck for your exam. Happy learning and good night. Bye bye.